Good morning, guys. In the previous session, we learned about the equivalent circuit diagram of a PN junction diode in normal working condition, which is in forward bias. This is the equivalent circuit diagram of a normal PN junction diode. Whereas in a reverse bias, the equivalent circuit diagram will be a resistor, a simple resistor. This resistor value will be in mega ohms as microamps current is flows. So obviously this value, resistance value, will be in mega ohms. This is the equivalent circuit of a practical diode. We are not talking about an ideal diode, we are talking about a practical diode. For a practical diode, forward bias equivalent circuit diagram. For the same practical diode, reverse bias equivalent circuit diagram. And our next topic is static and dynamic resistance. Now what is the static and dynamic resistance? Static resistance. Here static resistance means the resistance offered by the diode when a DC supply is applied across the diode. Simply means the resistance at a particular voltage. We plotted a graph. This is the graph via characteristics of a diode. At a particular voltage, for a DC supply means it is a constant voltage. Constant voltage means it will be some particular value, it will be assume at 2 volts. For a 2 volts, what is the resistance? That is nothing but a static resistance. So in conclusion, static resistance means resistance offered by a DC supply voltage, which will be a particular taking at an instant. At that particular instant, what is the voltage? At that particular instant, what is the current? With the help of those two values, we can calculate static resistance. Next, moving on to the dynamic resistance. Now what is a dynamic resistance means? It is a variable resistance. So for a change in voltage, we change the voltage from 2 volts to a particular 3 volts. So for a change in voltage, what is a change in current? We are going to measure change in current. So with the help of these four values, we are going to calculate the dynamic resistance, which is the resistance offered by the diode for an alternating or variable voltage. In simple words, we can say that for a DC supply, the resistance offered is nothing but a static resistance. For an AC supply, the resistance offered by the diode is nothing but a dynamic resistance. These are the formulas for a static and dynamic resistance. I think you calculated the you drew the VA characteristics. Dynamic resistance offered by the alternating or variable voltage source, whichever will be applied across a diode. Next, moving on to the next concept. Next concept is comparison of ideal and practical diode. Let's first discuss about the practical diode. Practical diode representation is similar to the representation of an ideal diode. Simple, a symbol, arrow symbol with a P and N on other side. P is also called as an anode. This one is also called as a cathode. So moving on to the equivalent circuit diagram. We discussed about the equivalent circuit diagram. That equivalent circuit diagram is for a practical diode. In reverse bias condition, I said a resistor of very high resistance, which is in mega ohms, is the equivalent circuit diagram for a diode in reverse bias condition. Next, moving on to the equivalent circuit diagram of an ideal diode. In under ideal condition, there should not be any barrier potential and there should not be any resistance, which is a diode forward resistance. So ignoring these two, eliminating these two elements, we will get a simple straight line, which is nothing but a conductor with a zero internal resistance. In reverse bias condition, the current should be zero. In ideal condition, ideally the current should be zero. So to get current zero, the resistance should be very high. So we will simply open circuit the terminals to represent the ideal diode in reverse bias condition. Moving on to the next point. Next point is related to the same equivalent circuit diagram. Next 3-4 points are related to the same equivalent circuit diagrams. So here the voltage or potential barrier we discussed VB. which will be 0.7 for silicon, 0.3 for germanium, is present in practical diode. In in ideal condition, there should be no barrier potential, so it will be 0. Similarly, forward resistance is 0, and there will be a little minor or a little small resistance is present in forward bias condition. And in reverse bias condition, the resistance, diode resistance, will be very high, and this will have a infinite diode resistance. Moving on to the depletion. Moving on to the depletion region. Depletion region means of a p-type there will be a small region in a diode. Practically, this depletion region will be microamps, which is 10 to the power of minus 3 10 to the power of minus 6, or it will be in angstrom. This is the unit to measure diameter of atoms. This is with the practical diode. Next, moving on to the ideal diode, the depletion region should be 0. Depletion region 0 untene barrier potential will be 0. Everything is interlinked. The knee voltage. Knee voltage means also called as potential barrier. Potential barrier should be 0. The knee voltage should be 0.7 or 0.3. Breakdown voltage. Breakdown voltage means in the VI characteristics we drew a breakdown voltage for iron 4007. It is 1000 volts, which is very high. Breakdown voltage is very high in practical diode, and breakdown voltage should be infinite in ideal diode, which means it should handle any amount of voltage in reverse bias condition.